So this is question 4 of the Winter 22 final exam walkthrough. So this question is all about caches and identifying the differences between the types of cache misses. So reading through this, it says we have an 8-bit processor. I don't think that really matters. With byte addressable memory that has a cache with the following configuration. So 32 bytes, a block size of 16 bytes. So that tells me that this cache contains 2 blocks. And then it tells me that this cache is directly mapped. Okay, so if the cache is directly mapped and I have 2 blocks, that means I'm going to have a set for each block. So that means I have 2 sets. And if I wanted to extend on that, I could say that this cache is going to have log 2 of 2 is equal to 1 set index bit. And because the block size is 16 bytes, that'll tell me the log of that, which is 4. That means my block offset is 4 bits. And so, yeah. So let's see what the question actually wants me to do. So it says, assume the cache was initially empty. Fill out the table with the provided sequence of references. If it was a miss, fill in the bubble. Okay, so this is a pretty standard question. So the first part of this question is essentially decomposing each of these addresses. The way I go about this is I like to just go through and decompose all of the addresses first. So it says, so I determined that the block offset was 4 bits. So that tells me, that the last 4 bits are all block offset. So then I also determined that I have 1 set index bit, right? Because I have 2 sets. And so that, yellow, tells me that this last bit right here is the set index, and everything else, so the first 3 bits here, are going to be the tag, right? So let's go ahead and just kind of copy that down. So the first 3 bits are always the tag. And then the set index is that last bit in that first 4 block clump. So it's awesome. So now we've determined the decomposition of these addresses, and it's asking us to determine the hit or miss patterns, right? So assuming my cache was initially empty on this first access, there's just no chance that we get a hit, right? Because our cache just doesn't contain anything. And so what type of cache miss is this? So as we were discussing earlier, compulsory miss is a type of miss when I've never accessed a block before, or that specific tag and set index block. And so as a result, I get a miss. And so that's what the scenario is for this particular case. But we also have capacity misses, which essentially say, assuming that the cache is fully associative, there just simply wasn't enough space to, our cache was simply not big enough to store that, to prevent an eviction, right? An eviction occurred because our cache wasn't big enough. The last type is conflict misses, which is misses that occur because my associativity was not fully associative. So in other words, if we assumed that the associativity was fully associative, and under the fully associative configuration, we would not have had a miss, then this is considered a conflict miss. But for this first one, we have a compulsory miss. And we are not evicting anything because our cache is empty. So remember, our cache can only contain 2 blocks, and it has 1 set for each of those. Okay. So then looking at the second access, we are accessing set index 0. So that is not going to conflict with the previous access. And that cache position is empty right now. We have never accessed this block before. And so it's going to be a miss for the same reason as earlier, and it's going to be compulsory. And we're not performing any evictions just yet. So then moving on to this third access. So we're going to look inside set index 1, and we're going to see if we have this tag 100. And it turns out we do, right? And we haven't evicted it. And so that means this is going to be a hit. And if we have a hit, then we don't need to fill out the next 2 boxes. Okay, so then looking at this fourth access, we are accessing set index 0. So that's the same one as our second access, but it has a different tag, right? So what that means is, well, first off, it's going to be a miss, right? And because we miss, right, we're going to need to bring it into our cache, and because we have a directly mapped cache, and there's only 1 block per set, that means we're going to have to evict this one. And so it asks us for the tag of the evicted block, and the tag of that is going to be 111. So what type of miss is this? Well, again, we've never seen this address before, and so it's going to be compulsory. We've never seen this combination of tag and set index bits. I need to clarify. Okay. Moving on to our next access. It says, so we're accessing set index 0 again. And remember, our set index 0 currently only contains the block with this tag, right? So when we look inside it, we see if it has 111, and we find out that it's a miss. Well, because it's a miss, we're going to end up having to move. We're going to end up having to evict this block. And so we're going to evict 011. So the question is, what type of miss is this? Well, for the first time, this is not a compulsory miss. The reason for that is that this access, or this combination, is the same as the one we accessed earlier. So this was caused by an eviction, right? And so if it's an eviction, that means it's one of a capacity miss or a conflict miss. So which one is it? Well, in order for us to determine that, we need to consider a fully associative cache, right? What would happen if we had a fully associative cache? Well, if we had a fully associative cache, so we really only need to look at these 4 accesses. If we had a fully associative cache, then we would have 2 blocks again. And so this would eat up 1 block. This would eat up the next block. And then this third block would still end up evicting our block. So in other words, even if we had a fully associative cache, we would have still gotten a miss here. And what that tells me is that this is a capacity miss. For this not to be a miss, we needed to have a bigger cache. Moving forward, we look at the 6th access. So this one is also looking at 0. And it looks at this combination right here. It does not match what is currently in the set. And so this is going to be a miss again. And what's going to get evicted is this block right here. So that's going to be 111. And once again, we have to consider this is not a compulsory miss because I have accessed this block before. I have, in fact, accessed it right here. And so once again, it's going to be one of a capacity or a conflict miss. Well, if we had a fully associative cache, then, well, this would have been loaded into the cache, into the first block of the cache. This would have been loaded into the second block of the cache. And then when we got here, we would have gotten a hit, right? We should have gotten a hit. But we got a miss under this cache configuration. So that tells me that this is a conflict miss. All right, I think that's the entirety of this question. Anybody have any questions or clarifications they want made? Let me monitor chat real quick. What about LRU? Wouldn't you evict 100 since that's the LRU for the second to last address access, right? So I think I just want to make sure I understand. I'm going to do something really quickly. So the question was for the second to last address, the second to last access, so this one right here, are we, why are we getting a, why wouldn't we evict 100 here? Well, the reason that we're evicting 011 instead is that address, the block with tag 100 belongs to set 1. Right? And because it belongs to set 1, these blocks, you know, this and this, or this and this, cannot belong to the same block because they belong in different sets. Does that answer your question? Oh, it looks like you were kind of figuring that out in chat. So, okay. Any last questions? Awesome.